Let me introduce our next speaker. So this session will be engaged by Mr. Mandeep Singh. He comes with more than 10 years of total experience in electronics and photonic design automation domain. In his current role with HR Universal Systems, he is committed for his contribution to the technical aspects of photonic designs and simulation with latest technologies and providing his specialized services as a turnkey solution to nearby all IITs, NITs, Indian defense, space, and research organizations, public institutions in India in the field of photonics up to the component level. He, with his team, is engaged with various projects for design, simulation, and optimization of components, links, systems, and networks for the dynamically growing field in photonic nanotechnology, optoelectronics, optical networks, and other photonic applications for ISRO SEC Ahmedabad, LASTEC Delhi, LRD Bangalore, ADA Bangalore, etc. Prior to that, he worked with Gigasoft India, New Delhi in Photonic Division as an assistant manager, managing the application-oriented services related to electronic and photonic design automation for India and SAARC region. In his past role, he has worked with organizations like AMD Limited, New Delhi, as an application engineer for technical support on digital and simulations. He holds Cadence, OptiWave, RHC, RHCI, and RHSS certificates. So now I am handling the session to Mr. Mandeep. So now this session is over to you, Mandeep. Yeah.
Thank you so much for this wonderful introduction, sir. So as per the topic, implementation of WDM links. So I shall be telling you how you can implement WDM network and how you can simulate it on a platform known as OptiSystem. So OptiSystem is a simulator for optical communication networks. So in a virtual environment, you can drag and drop the components, join them, and then you can simulate and see how your transmitter, channel, and as well as receiver is behaving. So in this regard, let's start with the OptiSystem with implementation of WDM networks. So first of all, we should know that what DWDM is. So in that case, so it will tell you how you can enhance your signals generated from different multiple optical carriers onto a single optical fiber. So in this, further, if we want to elaborate WDM systems, that can be categorized into further two categories, that is DWDM and CWDM. Dense wavelength division multiplexing, coarse wavelength division multiplexing. Once again, about WDM. So with WDM technique, or you can say a concept of WDM, in this, if in a fiber optical communication, we transfer the number of optical carrier signals onto a single optical fiber by using different wavelengths. Different wavelength means, for example, if we are using a laser source, then we can set the different type of wavelengths for each source. For example, if we start with a 4 channel or 8 channel or 16 channel, so in that case, whatever the optical signal or a laser source we are using, we can change the different wavelengths for each source. So in this, what we will be doing is, we will be understanding the basic concepts and the transmission modes structure of WDM, then how WDM transmission media will behave, means the WDM transmission media can be an optical fiber, or at last we can replace that optical fiber with a component related to free space optics, FSO. So first of all, within this, the technology specifications and at last the simulations. So now this will tell us how like these are effective for the transmission capacity. So in that case, for example, if we lay number of fibers for each category, then it will be a costly affair. But in case of a single fiber carrying all the different carriers, different signals, so it will be like a fruitful reimbursement of whatever we enhance in the project. So at the end, we will be getting benefited out of the project. We are using high bit rates, but not up to the mark. So I will let you know at that simulation platform what type of bit rates and at what level we are using that. So in that case, the complexity and the cost may increase if we increase the bit rate, right? So in that case, we should be like well versed with the level of using WDM links. So this is a graphical presentation how we can tell that WDM mux is mixing the different signals, combining at its port, and after that when it is fed to a fiber, so it will carry a number of signals. So this is just a sample of how it will behave. So first of all, for the concept, we will be carrying the number of wavelengths, means the specific wavelengths for each data. For example, whether it is a SDS signal, IP package, ATM cell, or you can say that telephonic lines, or you can say the defense people, those who are using their secret communications, so they can also use that. In other words, we are combining the different wavelengths onto a single optical fiber. So this is a block diagram. Basically, it is a unidirectional transmission. At a first end, the optical unit, basically this is the optical network unit from which we are feeding the number of signals to a mux, that is basically a WDM mux, passing through a channel. A channel could be a fiber, or for a further experimentation, we can also take up to the level of free space optics. After that, it is demuxed, and then we will be detecting it on a receiver and then comparing the results for our various analysis. For example, Q factors, the eye diagrams, the amplitude histograms, or how the fiber is behaving or a channel is behaving, is the number of attenuations or dispersions we are getting. So every calculation or experimentation can be oriented after the simulation through such kind of blocks. So this is a unidirectional transmission, whereas if we talk about bidirectional, means to and fro, means with the same channel we can use the bidirectional properties. So for these bidirectional properties, we have the components available with us, but this is a somewhat advanced level of WDM link transmission. So we will be moving through for a unidirectional transmissions only. Now in this WDM, so what actually depends? For example, when the transmission media passes through carrying a signal, so it also requires some amplification. So here we can use the amplifiers, for example, erbium dome amplifiers or optical fiber amplifiers, those who can give us gain at least 20 Gbps of gain, so that we can take the signal to further level at a transmission point. For example, so if we talk about the bandwidth, so it will nearly operate to 1550 nm, whereas we can start with 1370 nm also. But whereas 1550 nm is a perfect figure or a parameter, you can say, to operate. So in this, the bandwidth is given by a spectral range over which we can get adequate amplification. So whether it is a 10 dB for 50 kilometer or with the 50 kilometers at 0.2 dB per kilometer attenuation. So the attenuation can be varied. It depends upon the media you are using. If it is optical fiber, then 0.2, 0.4, 0.6 is okay. Whereas if we talk about a free space optics channel, means a wireless channel, so in that case we have to be careful with the surroundings, means terrestrial background. So in that case we need to feed the attenuation 4 to 6 dB per kilometer, or it is as per your link. So means how long the transmission and the receiving heads are placed, means what is the distance between the transmission and the receiving head. So this is a generic formula. So we are defining the wavelength and how specifically it can behave with the gain, whether the gain is from EDFA, that is erbium doped amplifier, or it is a optical amplifier, a normal optical amplifier. So in case we go for the delta function case of the wavelengths, if we perform, so in that case we can reach up to the level of 5 terahertz, but beyond that it is not possible as far as the virtual components also. So they can be operational 3 to 5 terahertz, but not more than that. So in this case, these limitations can be overcome with the wavelength division multiplexing. The limitation means the phenomena in which we reach a maximum point, or we can take the carrier signal at a maximum level, this frequency. So in that case, many different wavelengths share the same optical fiber or any media. But if we talk about earlier phenomenon, so in that case, the wavelengths earlier were separated by 10 nm bandwidth. So we can set down the bandwidth also for a particular component. In this case, we can move forward to 0.8 nm, which will prove it for DWDM, means dense wavelength division multiplexing. So now if we talk about the advantages, capacity upgrades. If each wavelength can support a bitrate of few Gbps, say 40 Gbps, then system capacity is increased massively by using many wavelengths. So we will get back to this part on the platform OptiSystem. So I will show you what type of bitrate we are setting here for the simulations. After transparency, each optical channel can support any signal format. So the signal format here it is shown is TDM, time division multiplexing, or any digital or analog. But whereas if we talk about the number of schemes, so the number of schemes can also be carried using WDM. For example, if you want to go through with the NRZ scheme before the modulation, so in that case you can put on the NRZ generator to generate the frequency of that scheme 0 and 1s, and then we can put on the carrier and modulate it and pass the signal through media. NRZ, RZ can also be performed along with BPSK as well as QAM techniques. So that can also be performed using WDM links. And even there are a lot of papers published using these WDM links, but it is like you can say more efficient if we use it with free space optics channel. So in that case, we can compare the different results used with different techniques, whether it is NRZ, RZ, BPSK or QM, so that accordingly we can compare the Q factors, we can compare the eye diagrams, eye height, amplitude histograms, and bit error rates for specific purpose. Wavelength, rerouting and switching. Can switch wavelengths and route signals by wavelengths, adding an extra dimension to the network design. For example, if I talk about a ring network or ring topology, so in that case, we have the availability for adding or dropping the components or adding or dropping the different carrier signals. So in that case, we can use WDM as a base, wave division multiplexing. And for an advanced stage, we can go through with the different topologies. For example, ring is one of the topology we can go through. For the further advantages, so the media is transparent. We can get long haul transmission, high capacity, use existing optical fibers. Very well, we can use that. High performance to cost ratio. Now, according to this, we can go through the SNR processes, means with the WDM analyzers, or you can say a calculator we have in Opti system. With this, we can see how signal to noise ratio is calculated at a part where we want to see the phenomena of SNR. So these are the different types with different parameters. So if we talk about CWDM and DWDM, so the channel spacing is different for each type. 20 nm for CWDM, 0.4 to 0.8 for DWDM. Wavelength range 1311 to 1611 nm, and for DWDM we can categorize into different bands, C and L band. So this varies according to the bands. Transmission capacity, so CWDM is as far as the lower part 40, but if we talk about DWDM, it is more than 600. Laser, uncooled laser, cooled laser, means these are some of the parametric phenomena which required during the transmission process of using WDM links. So as explained you earlier, we combine different wavelengths in a mux. Then with the combination at the output port, it is fed to a channel, and after the channel, it is splitted, or you can say the demux will do its exercise. So this is a part, mux and demux. In between, we can add the media also. So EDFA, erbium doped fiber amplifier, this is like anyone like can say that he knows about EDFA. Means if you need to amplify the data pass through a channel, so in that case you can use EDFA or any optical amplifier on how much you want to amplify the data. So these are the same topologies I have mentioned earlier. So you can use such kind of topologies. So this is one of the topologies, that is a ring network. So if you see here the number of wavelengths fed into a system, then we make a node, and from the node it splits into different portions and then again added into another system. Basically that is an optical network unit, ONUs you can say. So similarly we can add and drop any of the system from this ring network. It is a bit easy to handle such kind of networks. And if you want to extend it, you can easily extend that. So in respect to the smart city culture, if we say that, for example, the radius is 50 or 60 kilometers, so this is a very fruitful network. We can have it in the city using WDM networks. Now, talking about Opti system, so in that case, if we go through the applications, it includes, so these are the applications we can perform: optical communication system design from component to system level at physical layer, CATV or TDM, WDM network design, passive optical networks, free space optics, radio over fibers, SONET, any transmission or a receiver channel based project, dispersion map designing, estimation of bit error rates, and various type of amplified, or you can say the doped amplifiers available to analyze the different calculations. This is a front portion of the system. This is a generic WDM transmission. So this is 8 channel, whereas if you want to start with 4 channel, you can also start with. But in this case, let me jump to the software part where we can see the different aspects. This is Opti system 17.1. Some of you may have 17.0 also. This is somewhat, you can say, a latest one. So if we start with a scratch, let me start with this. First of all, regarding the implementation of WDM link, should have transmitters with us. So it's a common source. I request everyone to mute their microphones. Okay, so starting with the transmission of WDM link. So this is WDM MUX 8 by 1 channel. So this makes it different. So we are using pseudo random bits. So pseudo random bits will be as per the bitrate mentioned for the layout. In that case, you need to set the sequence length and samples per bit. Means similarly, the toggle we have available, auto connect on move, will automatically get connected after every modulation port, means after every Mach Zehnder modulator. So in that case, we are using laser, random bit generator, RZ pulse generator. So now, before I simulate, let me check the optical spectrum. But here, what you need to do is, so as per WDM link definition, the number of signals with different frequencies means we need to change the frequency. For example, let it be 193.2 terahertz for second, and in continuous version we can go through that. All these components are available in the component library of OptiSystem. So in case you need to find a component, right click on this area, find component. For example, if you are looking for a WDM mux, just type WDM. Here related to WDM, you will be getting all the components. For example, I have used this mux, so that is this one. So that is available under WDM multiplexers library, multiplexers. Similarly, for each and every component, you can write down a keyword here and search. And once you double click on the component, it will jump to the specific location inside a library. The spectrum analyzer, this is available inside your visualizers library. So this is a category under optical visualizers. So optical spectrum is this one I am using here. So now I have changed the frequency of every input for this WDM mux. In that case, if I simulate it again, so now you can see that at these are the different frequencies it is being transmitted. So this is our transmission part. Up to this level, this is okay. Now we need to have some media. So in that case, I will be using optical fiber. And again, multiplexer. A detector at a single port. Now this is a generic WDM link. So to enhance it, you need to do R&D. So in that case, for example, I am using this only for a 50 kilometers length. And if I want to see BER, let me tell you the concept of BER also. This is a very important component. So in that case, this is port component. First port will take a input of a binary signal. Second, electrical signal, that is a reference one. And this is electrical signal as an input. So let us simulate it and see what we are getting after 50 kilometers length of optical fiber. Okay, fine, we are getting some I diagram, some random Q factor. This is okay, this is not bad. But whereas if we enhance it, for example, I use this loop control. FA, you can say, just have a normal optical amplifier with 20 dB gain. What if the number of loops are 5? 5 into 50, 250 kilometers. And here, filter that section. Let me increase the iterations, means the number of runs. Okay, now if we calculate it, in these cases, you may get to know how you can combine the signals on various wavelengths, and then at a receiver end, you demodulate it, demux it, and relatively get the results at each port. So basically, this is for 8 channels. You can go beyond 16 up to 32 also, but it depends upon the various factors. So now our optical fiber is propagating. It may take 1 or 2 minutes.
Complete.
Amandeep sir, what are the standard values for Q factor as well as the BER for generally range of let us say 100 to 500 kilometers?
Sir, your Q factor should, your graphical representation should make a peak. A peak when you simulate it. So let me show you how you get a peak here. So whatever the Q factor is, like 6, 10, 12, more than 100, so you can have it as a positive sign, but whereas it should get with a peak, not with a slope or curvy graph, you should have a peak of Q factor. And in this case, the last BER I have simulated is approximately 1.59. So that is 1.59 e raised to the power minus 0.34. So that is a huge, but in that is very less for such kind of WDM link simulations.
Yeah, because sir, general link and all are like that link 10 raised to minus 9 to 10 raised to minus 12. That is the sum of.
Yeah, that is for wireless links. But here we are using optical fiber. Yeah. Can you please repeat it again? It is interrupting. Hello. So I can read in chat. So Dr. Rasikran, open source simulator, I don't know, but yeah, there are some open source simulators available, but not for optical simulations, optical network simulations. So you can get OptiSystem for 30 days or for like 2 months free of cost for your evaluations. In case you want to have it, you can download it from optiwave.com, or you can get it from Dr. Amit Garg. We have provided him. Yes, there is a chance. There is a chance. This is purely an R&D. If you increase the number of users, there are chances of increasing the BER. But this is the only phenomena if you are using loop control, means for a looping purpose. So loop control will help you a lot. And apart from this, the iterations means the number of runs you are optimizing for this particular project in OptiSystem. So that will help you to get it less, means the BER, like it will give a less effect to the BER. Yeah, very well. You can use OptiSystem for underwater wireless optical communication. You can go through different type of IEEE or Elsevier papers. So they are purely written using these OptiSystem simulations. So for that, you can use FSO component, and for that, you can use its terrestrial links, means you can change the scintillation effects, gamma or to log normal. So these are some of the atmospheric conditions you have to take care of. Yes, this is possible. Yes, OptiSystem is one of the software. You can use it for designing optical amplifier and visible light communication. See, for NRZ scheme, as per your question, you can use various techniques, not only NRZ. You can use RZ also, CZ also. Apart from that, you can use QAM technique. So that will also help you. Okay, regarding sequence length and sample per bit. So you have to be careful when you start designing your components. So in that case, if you double click on the layout, so that will give you a brief short parametric window where you can adjust your sequence length as well as bits. It depends upon the signal you want to generate and you want to focus on. It comes under the global parameters, and for further enhancing it, you need to be very specific regarding the sequence length. It should not be less than, you can say, 92, but 128 is okay. And samples per bit is the per bit you generate or you transmit, it should have, you can say, at least 32 bits per sample.
Sir, is there any relation to choose?
Your voice is distorting. Can you please speak slowly? You can write it on the chat box.
$64. So sample per bit, can we take 32 or 128?
For 64, corresponding sequence length will be 128. This is a hit and trial method. You can use that. But in that case, you have to be careful regarding the sample rate.
We have taken a sequence with that much, so we have to take sample per bit that much, or we can take it and trial it.
For example, in the simulations, you are using lower bits, lesser bits, you can say lower bits for your simulation, and you have set the length and sample per bit is beyond its capacity. So it will not show you the results. So the results cannot be obtained. So it will be mingled somewhere else. But in case if you go with the normalized parameters, for example, 120 sequence length and 64 sample bits. So in that case, it will give you somehow some of the results. In such cases, okay, I request everyone to mute their microphones. Okay, coming back to this project. So this is one of the project. This is a similar one I have simulated earlier before starting my this. So here in similar way, whatever I have designed here. So this is the same one. I am using the number of loops 5 and optical length is 100 meters with optical amplifier 20 dB, the same concept.
जब ये इसका माइक ऑन हो गया लेकिन बंद
Okay, so this is the one we have already simulated.
बात कर रहे हैं
Let me start again. So these are the different wavelengths with signals I'm using. After modulation, I'm feeding it into WDM mux, that is 8 channel. Then I'm using a loop control method. Loop control method is used to the number of runs. For example, here I can change the number of loops. So it is a multiple factor 5 into 500 kilometers for 500 kilometers. So at one of the port, I am detecting the signal. With low pass Bessel filter, it is filtering. And at last, I am using this BER analyzer for comparing the results, whatever the input given at the transmission part means the binary signal and the electrical signal, along with the comparison of this data we have detected at photodetector pin.
हेलो
So in that case, I have used 5 iterations. 5 iterations. You can use it 2, 3, 4, 10 or n number of iterations. I request everyone to mute their mic. Okay, here if we see the lowest bit error rate I am getting it in second iteration, that is 1.59. You can say 1.60 exponential minus 0.34. It's a very less error, very small error for WDM links. Whereas if you can see here, the length I am using is for 500 kilometers. So the normal length for optical fiber here is 100 kilometers. This was the spectrum I am getting before the transmission, and after passing through the optical fiber and all. So this is the spectrum I am getting. It means that at each wavelength I am getting my data after 500 kilometers. So if we talk about a lowest range, so if you want to go through with the proper WDM link, which is for smart city purpose, so in that case you can choose 50 kilometers for optical fiber and optical control, loop control you can say, so that is 5. So it will not go beyond 250 kilometers. So the results will be better. And for generating reports for WDM link transmission, you can go through the BER analyzer graphs. So this is the amplitude histogram for various iterations, amplitude probability, is constant, threshold, the bit error pattern, amplitude with respect to time, and this is eye diagram, and this is the Q factor. So you can see here, so the number, we are getting the peaks over here. So these results are basically for various iterations, means number of runs. So we need to give iterations sometimes to compare some of the sweep values so that it can show us the generic result. So these are the 5 iteration values. So in case you want to make a legend, so you can label that. So these are the Q factors for particular iteration. So from here, from this report generation format, you can generate your results. Apart from that, if you want to go through with the spectrums, sample signal spectrum, this is a sample signal spectrum before moving ahead through optical fiber, and these are after getting a signals passed through optical fiber. So in the same layout, what if we use free space optics as a media? So basically, there is one of research paper you can say published for testing FSO WDM communication system. So that has been published by Mr. Vladimir from Russia. So in that case, he used 1400 meters as a range. But here, if I delete this, if I simulate it, let us see something. Okay, this is hodgepodge. Let it be. So in that case, for FSO channel, you have to be very careful regarding transmitters and receiver setting.
Hello, sir. There is some noise from that Balwant, sir. Please switch off your mic, sir.
Bhatti ji? Hello? Yes, Balwant Singh, can you please turn off your mic? Mandeep Singh,
Yes, sir.
can you please turn off this Balwant Singh mic? I think you have control. Just check.
Yeah.
Yeah. You are the presenter now. Click on this Balwant Singh and then check if possible. No. Okay, so I'll just connecting with.
For sure, please.
Okay, yeah, you can continue. Yeah.
Hello.
Hello.
Hello. Hello. Excuse me, sir.
Yeah.
Hello.
Yeah.
In the designing part, we are using one low pass optical basal filter after pin diode. Okay.
Okay.
But
Okay.
sir, in the demuxing part, the demux which are using, if we click the WDM demux, then we can one parameter in the main parameter. There is one filter type. What is its significance? Please click on
What?
the. Please
What?
click on the demux. Please click on
Okay.
the demux.
Okay.
And there is one filter type in the main parameter. It can be changed to Bessel filter or triangular or any other. Okay, rectangular
That
or
is.
Gaussian.
Yes. 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 So in that case,
And
this.
if we change this filter, the bar and IV diagram also it will be also changing.
Yes, definitely. It will be affecting your result.
Results.
Yeah,
So what
definitely.
is its significance?
Its significance depends upon the signal you are using. For example, sine wave or
Yeah.
rectangular wave. So accordingly, you can use the theory, pattern
Yes,
theory.
if we use the RZ signal, then the filter type will be rectangle. Okay, but there are
Yes.
filters we are using. In the demux part, there is one filter, and again we are using one filter in the after.
Be- because I need more clarity. So that is not sufficient for me. So in case after these simulations, if I need to put another filter again, I will definitely do that. Or in that case, I can change the cutoff frequency.
Yes, yes.
So
There
here,
in Bessel filter, there you use the main function is a cutoff frequency. Yes.
exactly, exactly. So I can change the cutoff frequency according to my requirement. Whereas this is not sufficient for me. So in case you want to compare, for example, for your own understanding, if you want to compare this, you can use the oscilloscope visualizer or any visualizer to verify the signal and its representation. So at this first portion where your signal is proceeding, you can use that oscilloscope, and at this portion also you can use that oscilloscope. So in that case, you can
Okay.
result whatever you require, and accordingly you can use your filters or amplifiers or whatever you require.
Okay.
Yeah. Okay, now so coming back to this FSO link. So in this FSO link, basically this is a WDM wireless link. So I have replaced optical fiber with this free space optics channel. This free space optics channel will give you an environment to change the properties of the signal or data it is transmitting to within its channel. So in that case, these are the sum of geometrical losses. You have to always tick that geometrical losses, attenuation, by default value was 25. I have lowered it to 4 dB per kilometer. But in case of foggy or rainy circumstances, it should go beyond 12. So these are some of the thumb rules. You can find it on Google or any of the research papers. So in that case, your attenuation depends upon the atmospheric conditions, right? Apart from this, we have the transmission and receiver's heads, means the distance between them. So the transmitter aperture diameter 5 centimeter, receiver aperture diameter is 20 centimeters. So in that case, I have tried to simulate it, whereas I am getting a eye diagram with the proper height also. It means that, okay, after like transmitting it through 500 meters, for example, a building next to your door. So in that case, the another receiver, the guy who is standing with the receiver there, so he will be getting the data. But the quality factor is low, the peak is not up to the mark. So these are some of the circumstances. So this is what you can get. But in case you want to perform it for underwater communication, you can say. So for underwater communication, your this scintillation model will change on. For example, this is gamma, gamma, and log normal. So these are some of the scintillation models. So there are some typical stories behind that. So for particular scintillation models, you can use your communication for underwater phenomena. In that case, you can set the attenuation 16, or if the density of water is more, you can keep it 25. And the transmission aperture, you can set it according to your practical implementation.
I mean, Amandeep sir,
Yes, sir.
what is the meaning of range here? What you have said for 500 meters, something like that.
Range means, for example, it is the range between transmitter and receiver.
So in that case, sir, this can't be used for a longer distance, na?
No, not more than 1400 meters.
Yes, yes, sir.
The actual paper published by Mr. Vladimir from Russia. So he proposed communication of WDM link through FSO with 1400 meter range.
1400.
Yeah, there may be availability of like IEEE research papers. You can
Yes,
go.
sir.
So in case you want to improve that range, you can also do. But here, apart from FSO, we also have OWC channel. So this is basically used for long distance communication. You can say inter-satellite or ground to earth, or earth to earth to satellite or satellite to earth. So if
Yes,
I
sir.
with this, here the temporary, or you can say the default range is 200, but let it be for example 100. If I simulate it, simulation also depends upon the RAM of your system. So
Yes, sir.
it should be more than 8 for fast calculations. Okay,
Yes, sir.
I am getting a perfect peak, but the Q factor is 3.4. Never mind. Eye diagram is not good at all.
Yes, sir.
But let me check for other iterations. So these are different iterations I am using here. And in this case, for example, I am feeding optical signal. For that, use you can see the effect optical amplifier. I'm using an optical amplifier. Now the Q factor reached to 75. Minimum bit error rate is 0. So this is a peak threshold, right? So everything we are getting here is good. So at various iterations, I'm getting various results. So in this case, single iteration is more than sufficient. I have used 5 iterations.
Sir, here in this screen itself, like we are getting some pattern 1, pattern 2, pattern 3. What is the meaning of that thing, sir?
Talking about this,
Yes. Yes, sir. Yes, sir. Shall we have to take the average of that thing or something like that? What's significant? Because normally it is available in each and every analysis and all.
sir, actually these are the legends marked
Okay.
for every parameter. So
Okay.
you need not to worry about this, but whereas these analysis results are important. So this one. So these are important. And apart from this, as explained you earlier, this in this report generation part, your this amplitude histogram and all these parameters, these are very important.
Yes, sir.
So now with this, what we understand from this WDM link means collectively feed various signals, various wavelengths into a single channel, whether it is optical or wireless. And after demuxing it, we are getting eye diagram as well as quality, right? Okay, now the quality from word. So here we have WDM analyzer as well. So after this mux, I am using this, and as well as after this amplification. So again, if I simulate it, now I have ample of data to compare the results, right? So I will show you how analyzer will give you point to point result. These are the various frequencies we have used. These are the signal power with noise power, with signal to noise ratio. You can make a chart out of it, signal to noise ratio, then optical signal to noise ratio with the signal power minimum to maximum value with the ratios also. So these will help you a lot to collect the data. WDM analyzer. So this was at this portion. And now if I talk about this, so these are the various signal to noise ratios. So it gets decreased. Signal noise ratio is also less. Again, we have details for minimum to maximum value and other total ratios. So in this way, you can the data at each portion. So this is about WDM link, and further now just more than 5 minutes. So the people.
Hello.
Hello.
Yes, actually, I would like to ask one question.
Yeah, sure.
Actually, missed how you plotted the multiple Q factors in a single graph. Can you please?
Okay. Then again, I will be shifting to the software.
Or you can do tomorrow also if okay, it is opening. Yeah.
Yeah,
No problem.
it's okay, not an issue.
Yeah.
So your question is how
Suppose we are transmitting 8 wavelengths. Okay. So at the receiver side, basically we are having 8 BER patterns or 8 Q factors. So how you combine these 8? How many wavelengths are there basically?
we are using 8 wavelengths.
8 wavelengths. So how you combine these 8 ops? Where this option is available in this opti system?
See, actually, if you go through this phenomena, this is a carrier wave we are using, laser. So
Yes.
bits are generated, NRZ pulse generator, then it is modulated using MZ modulator.
No,
Then
that is okay.
this,
How to plot? Okay, so suppose come on the spectrum analyzer.
okay, this one.
Yes. So okay, this is available. Check plot the Q factor. That
Oh,
is from BE analyzer, I think.
yeah, BER analyzer. For example, I am using this setup for a single port. This is a single port, and for
Yes.
rest of the 7 ports, I
Huh?
need to do the same. Means
Yeah, this is basically demultiplexed signal, so it is one of the single channel signal. That's why it is a single one. And for
No,
five,
no,
exactly.
I am not.
and for
Actually,
five,
just show me that Q factor. You have shown the Q factor. Huh?
no,
Q
for
curve, that
five,
is base
it
shape
was for
curve.
5 iterations, sir. It was for 5 iterations. For each
It is.
iteration, sir has shown that thing.
No, no. Amandeep,
Yes, sir.
just show
I'm
me that curve, bell shape, Gaussian like curve you indicated. अभी दिखाया था ना कुछ?
this
Yes,
one.
this one. So
Okay,
what this curve is indicating? This is for iteration 5.
these are for 5 iterations, and for simplify it, let me set it to 1 and let me simulate it again. So this will rectify. So basically, we go for various iterations just to
So
know.
now you are how this curve you got? I actually missed this part.
Okay, sir.
Report
Actually,
section basically.
Just pick the
this is.
result and put it in the plot browser.
Let me do it again. I'm deleting this. So now under this, we have a option available at left hand side. This is a project browser. So under that, we have a BER analyzer component.
Hmm.
Under that, we have a graphs. So
Okay.
under graphs, we have all the calculated results.
Okay, so click on some BER graph, BER pattern 1. Yes, on this.
This is minimum bit error rate.
Okay, and if this is for multiple iterations, suppose 8 iterations, then we will get 8 curves, right?
This is for single iteration.
Okay, yeah, okay, got it. Yeah,
Yeah, for 8 iterations, you have to set the iterations from this location.
yeah, it is clear. Yes, no problem.
And the use of iteration is just to compare. Actually, the algorithms which are written behind every component have some variations of 1 or 2 points, because the 100% efficiency is not possible. It is a generic law.
Okay.
In that case, the iterations are required to compare the results what you have simulated earlier, right? So this will a minute up and down, but the result will be means sure. It's a surety you get the results.
Yes, yeah.
Okay. Any question related to the software part?
Hello, sir.
Yes, Amandeep sir, I have one question.
Yeah, please.
Yes, I am a regular user of Opti system in
Okay.
our lab from
Yeah.
Alia University, Kolkata.
Yeah.
And at first, I am grateful to you because in this pandemic situation, earlier from the month of April to October, you have provided free server link to students.
Thanks to everyone and thanks to OptiWave.
Yes, thanks to Opti. Because of that, we have done lots of work
Yeah.
from
Yeah.
our home.
Yeah. Correct.
Basically, we are facing one problem in the report browser while we are plotting the graph. In the
Okay.
journals, they are telling that all the line word graphs should be 600 dpi. Okay, but while we are plotting the line word graph and saving it, the dpi is decreasing. How we can increase the dpi?
The first solution
100.
the first solution is you simply right click on your desktop and go to the graphical properties. From there, use the pixels not less than 1200 into 720 pixels, not less than that. And in that configuration, when you generate,
Please show me one example.
okay, I cannot tell you exactly the example, but in case, for example,
Basically, we are facing this problem in the comparison graphs in the report browser while we are drawing the multiple graphs, comparison parameter in a single graph. At that time, the DPI is not 600. Yes. Yes, sir.
example, I am using this, and the best part is you can zoom out or zoom in a particular area
Yes, yes,
and go to the
yes.
legend part. This will like enhance the clarity.
Okay.
Your DPI question related to the clarity of the picturization depends upon the graphic card you are using for your desktop or system. Means my first suggestion to you is always like set it to 1200 to 720 as a screen width or a area for
Okay.
your this whole screen, right?
Okay.
You go into the properties, the graphical properties.
Okay.
So that is a generic portion. You can do that. Or in case you have
Okay.
any specific question, you can email to us at info@hrunisis.com. So definitely we
Okay.
will
Thank you.
give
Thank
you.
you. Thank you. Thank you.
Hello, sir.
Hello, sir. Amandeep, sir. Hello.
Yeah, please.
Hello.
Yes, yes.
Uh, Myself, Astaful from Kolkata.
Yeah, good afternoon, sir. Yeah.
Please stay in this. Okay.
Yeah, sure.
Sir, if I want to make this legend portion,
Hmm.
it is showing different three colors, na?
Yeah.
That is green, red, and uh, I think
Red, maroon, and green.
maroon. These three colors are there. Suppose I want to make this legend part inside
Okay.
the graph. Okay.
Okay. Uh,
So whenever you put within that, it is actually diminishing the area. And second thing, if I want to make it black and white with
okay.
different suppose bullet form and dot form, how can I do that?
Okay. So
So
you
I want to make a black and white curve, suppose, and I want to differentiate different curves with different types of bullets. Okay, circular or triangular like that. And also I want to make this legend part inside the curve so that the curve will be compact, that the total uh, graph will be compact.
okay, sir. First of all, regarding the curve, you can change the authenticity of this curve, means the colors and all
Yeah.
from this location. So
Hmm.
repeat this step again. You go to the properties and click on this curve. And for
Hmm.
each curve, there is a different color. So you can change
Yeah.
the color accordingly.
This color to black and white, and we can make the line width. That's okay.
Yeah, yeah, you can use that. Apart from this, the
Okay.
plot style. So plot style could be a line, segment, left to right,
Yeah.
center. You can
Yeah.
set this plot style and point style. That is circular, square, diamond, cross.
Yes. Yes.
So
Yes.
you can use this. Apart from
That
this,
is there.
the thickness or the dot you were referring to, so that can be
Yeah.
changed on this location style.
Okay.
So for
That's
example,
nice. Now if I want to make this legend portion, which is right side,
okay,
want to make it in the corner, left up corner, left top corner, suppose.
okay,
Then the graph itself actually reduces graph area.
so you can place it anywhere where your result is not overlapping. Yeah, like this is not overlapping your result. So according to this graph, this is okay. Whereas you can take it anywhere. This depends upon you where you want to place it. You can make it shorter. I hope this clarifies.
I think it is
Okay,
for
I will
the 17 version.
It is available since version 10.
But in 13 version, the graph is compressing.
You can do that. Please let me know, or our technical team.
चलो ठीक है okay, we will check it. Okay, thank you.
Yeah, sure.
Thank
sure.
you very much. Okay.
Welcome, sir. Yeah, any other question?
Hello, sir.
Yeah.
Yeah, if we are using the free space optics outside, that is indoor communication for outdoor communication, if we are doing, then
Okay.
then there are issues like interference with other light sources. Like in daylight, sunlight is the main thing that we can have the interference with. So how to show it with this simulation with this opti system?
See, within a single question, you tell me how I can explain you everything, because this is basically a research. And as I explained you earlier, for this FSO channel, or in other words, as you were saying, for indoor communication. So in this part, you need to go through some research papers, or Google it, or write it to us, so that we can help you to set the parameters according to the atmospheric conditions as per the sunlight and all. So it all affects the geometrical losses, attenuation, and somewhat scintillation model is also like effective for this. So in that case, you need to like learn or for your own from Google or from some papers. Write to us, we can definitely help you out.
Okay.
So all about
Okay.
the parameters, you definitely get the results.
Yeah. Thank you, sir.
Yeah. Any other question?
Sir, yes, sir. Can we measure the phase noise using OptiWave software, OptiSystem software?
Phase noise in what sense, sir? At which point? Means transmission level, or what part?
Suppose in a fiber we transmit the signal. So
Okay.
after reflection, definitely there is a phase change.
Exactly.
Yeah. How can we measure that phase factor?
Phase factor you can do in terms of applying some jitters.
No, sir. I am asking about. Suppose initially I launched into the fiber.
Okay.
E per j omega CT plus some 10 degree in the sense beta phase shift.
Okay.
So after reflection, the phase angle is varied.
Okay.
So how can we obtain or how can we measure the phase change?
The phase change can be measured. Actually, we can measure that, but we have to convert it to the corresponding time domain frequency. Means in that case, we need different type of jitters, so that we can convert it to a radio frequency and get the results, or with a script. So with
You are telling based on the calculation.
I'm telling you the based on the calculation. Yes.
Yeah, I know. I am asking in OptiSystem software. Suppose the phase shift is 180 degree in the sense.
Okay.
In the spectrum analyzer shows the same value without any phase change. So opposite direction is not there.
Okay. Okay, yes, you can do that. I know that it can be done, but right now I cannot show you like how you can do that. But it can be performed using this OptiSystem platform.
Okay, sir. Okay. Can you share your email ID in the chat box, sir?
Definitely. I will be writing my email ID.
Okay. So in optical wireless channel, how can we connect the optical amplifiers, sir?
Wireless channel, how can we connect?
In real time, I'm asking in real time. So WDM mux is there, WDM DMX is there. In between optical wireless channel.
For example, if for any reason you are connecting a pin over here, for example, for any reason you are connecting a pin, this one, can you see
So
that?
optical, sorry sir, optical amplifier is connected before the demux.
Before the demux, yes.
Yeah. So initially the beam is divergence.
Yes.
How can the signal is amplified without a collimating lens or?
See it as I told you earlier, it all depends upon the algorithm it is written on. So its algorithm is written to have a input of optical signal. It could be a wireless or it could be through any channel, for example, fiber also. So any optical channel, it can take it as an input. So that is
Okay,
the
sir. In optical fiber cable, not an issue. In
okay,
wireless medium, definitely the divergence is takes place.
exactly.
Yeah.
Must be a receiver. There must be a receiver to detect everything, right? And after that, we need to amplify it, then feed it to demux, and then at each port we can calculate it. But in this case, if I talk about this optical amplifier, this one, so in that case, it is made and its algorithm is such like it takes an input of an optical signal. In reality, I know that I can understand your question. You are right. But in this case, it's in virtual phenomena, you can get it and simulate the result. So it will be complex if we like add anything further or lenses or something like that. We can add that. Even lenses are available in this optic system also. We clearly get an input from OWC channel, then why to connect that?
Okay, sir. Thank you.
I do hope it clarifying.
Thank you, sir. Thank you so much.
Yeah, yeah. Anybody?
Hello,
Okay,
sir.
so- yes, please.
Hello, sir. Sir, here there is a WDM mux and WDM demux. So there is a one parameter in that it's a bandwidth, and generally it's set to 10. So is there any significance of that if we change that bandwidth to 10 to 20, 30 or 40?
Mux or demux, both okay.
Both have a bandwidth, yeah.
In this, if I go to this help option,
Sir, it is given a 10 gigahertz by default.
see the minimum or the value you can take is 3 dB. That is a filter bandwidth. Default value is 10. So you can vary this from this to this value.
From 10 to
3 from 3.
3 to 10, but not beyond 10.
You can use that. Then you have to figure it out using these scenarios. Whatever the simulation parameters required for the simulation, so other parameters should also be taken off.
So means on trial and error base we have to check.
Exactly. This is known as R&D.
The same thing is happening with data rate also, sir. In some paper I have seen they have used 80 Gbps and 100 Gbps with a 0.2 nanometer spacing or 0.1 nanometer spacing. But exactly when we fit this all, we are not getting that much exact result.
See, the main motive of every research, it should be cost effective and it should be less complex, right? So when these things are available in your research, so automatically you can get it published, right? But in case the complexity and the cost effectiveness is great and higher, so in that case you need to take care of such kind of parameters. So every parameter can increase the money behind that, right? So that is the main motive.
Okay, sir. Thank you, sir.
Yeah. Yeah, Dr. Amit, I think it's 4, 5.
Yes,
Yeah.
yes. We can take over tomorrow also.
Sure, sure, sir, sure.
Yes, so tomorrow we also have one session from Mr. Amandeep. So I think you all will again enjoy and you'll clarify your doubts. Okay, so we are just now close to this session. So we are ending this session and there is one information. So please join us tomorrow morning at before 10 a.m. Basically just 5 to 10 minutes before. The link will be activated 10 to 15 minutes prior to the time. Okay, and tomorrow you'll have the session from Professor Anand Srivastav, that is from IIIT Delhi. He worked in IIT Delhi as well as in IIT Mandi. So I think you'll have another great session tomorrow. So now I would like to thank Mr. Amandeep Singh for his great and very interactive session. So thank you, Amandeep, and we are hoping one more and another enjoyable and informative session from your side. Yes, thank you so much.
Sure. Thank you so much. Thank you, everyone. Bye-bye.
Yes, so thank you all the
Thank you.
participants.
Thank you,
Enjoy.
sir. Thank you very much, sir. Thank you very much, sir.
Thank you. Okay.
Thank you very much, sir.
Thank you. Thank
You're
you.
welcome. You're welcome.
Thank you, sir.
Thank you, sir. Hello, thank you, sir.
You're welcome. And my one request to all the participants, kindly join all the sessions. You'll have lots of information. It will be useful for your research and you'll have certificate. Yes. Okay, thank you all. So you may leave the meeting and we are just now ending this meeting. So thank you all once again. Thank you. Yes. So Savita, your voice is basically not very clear. Yes, can you please tell us? Yeah. So basically for recorded videos, we need to take the permission from the respective presenter. Okay. We'll try to take the permission and if they permit, then we'll definitely select with you. We'll share, I think, these videos on through YouTube. Okay, but before that, we need to take the permission from the presenter. Yes,
Yes, sir.
attendance will be marked through online session. Yes, basically, we are separately having one meeting for one session. Okay, so that's why we end the meeting and then again we start the meeting. So we have multiple meetings. So in the database of Webex, we can fetch the details of the participants who joined, at what time they joined, and up to what time they joined the meeting. Yes, so it's not a problem. Yeah. Okay, thank you all. Enjoy your day.
Thank you.